we're going to jump right into the hardware overview and kind of break down the sheet metal, break down the array in and of itself, and kind of get into what the first slide here, what I like to call the ice cream truck, right? So here's all the different flavors of PowerStore. We have two different deployment methodologies within PowerStore. We have the PowerStore T and the PowerStore X. We'll go through those differentiators as we progress through the session and presentation. But just know that both the T and the X are actually using the same hardware. They're using the exact same storage array, the exact same controllers, and the exact same specifications as far as hardware. You'll see we have the 1,000 is where we kind of start out, and then we can scale that up to the 9,000. These all
Hey, Jodey,
yes.
the NVMe SEM drives, you've got NVMe SEM and NVMe Flash. Are there limitations on both of those, or? You mentioned 384 drives here, but...
Yeah, so on the NVMe SCM, on SCM devices, we populate those on the base enclosure only, and actually have a slide that'll talk about that. So we'll actually show you the population methodologies and capabilities of the individual drive types.
But before continuing, I don't know if you catch on this later, but actually, so you talked about a confusing portfolio, which... we all agree, and we are all happy that you are, harmonizing somehow the portfolio with this new product. But what is the migration path from, all the platforms to this new one? I mean, since you talked with all your customers, and they are all EMC customers, of course, and you have Unity and the
SC and yeah.
So
Enrico, I hear you.
So we do have a slide, and we're going to be talking about that a little bit later in the presentation. So, if you don't mind, kind of let that flow, but we'll definitely answer that question for you. Okay.
Yeah, we'll talk directly about it. And Enrico, I'll also show you that in the interface. I'll show you how simple it is for those pre-existing customers to bring data in.
Yeah, and I do want to mention, I do have some color to add, to the hardware here. So you can see from a PowerStore 1000, 32 cores, all the way up to a PowerStore 9000. That's for our PowerStore T model. If you take a look at the PowerStore X model, where we have an embedded ESX hypervisor, where we're able to take on applications, customer applications, running alongside our storage function. Roughly half of the resources are available to serve the storage array functions, and the other half are dedicated, directly to user VMs. We are going to talk about the PowerStore X implementation, but what I wanted to say was that the choice to use 50% of the resources for the storage function and 50% of the resources for user applications was a design choice that we made. We really need to kind of see how our customers are really going to leverage, the number of cores that they really need for their applications. So in our first release, this was fixed. It is what it is not. It is not an indication of, how heavy our storage VM is. It's just simply how many cores we're dedicating for serving storage at the same time hosting applications. And you'll see along the roadmap where we'll begin to give choice for customers where they can flex that deviation. If they have more storage heavy, external serving capabilities, they can assign more cores for that. If they have, more user VMs, less storage intensive in a small footprint, they can actually add more cores for user VMs.
So go ahead, Enrico, go.
Okay, thank you. So you're talking about 50% of resources freed for applications, but actually what happens when a failure occurs? So if I lose one of the two controllers, okay, I lose 50% of that 50%, meaning that I have only 25%. Is it enough to run my workloads at full power, so full throughput, full everything?
Or so it's a fully symmetric active architecture, right? So if you're going to exceed the capability of both controllers, or more than 50% of the resources in the array, and you don't have another appliance where you can migrate that VM to, you're gonna exceed the capability of the array, right? So But in
So,
general,
Within our sizer, so when we're working with a customer to deploy, let's say, a PowerStore X implementation, we have the ability to take all of their requirements, virtual CPU, virtual memory. We can plug those indicators into our sizer. We can do planning, so to kind of understand where does the customer need to be, where are they wanting to go, how much headroom do they need. We can work with the customer to make those determinations through our sizing tools before we do an implementation.
all right. So my question is in the X series, where you are where you have a ESX virtual machine and all that stuff, are you still servicing Fiber Channel, iSCSI, and those sorts of IOs as well outside of the virtual environment?
We are.
absolutely. Matter of fact, why don't we just jump to that slide right
Sorry.
No, let's. Let me.
This is something that others keep asking out, and I kind of want to clear the fear, uncertainty, and doubt around the implementation, because we do have a unique implementation where we've actually filed some patents on that, and we're waiting for them to be issued. But jump right down to my slide where I have the guest VM architecture. Next slide. This one right here. Okay, so what you're looking at on the right-hand side is a single controller. There's actually two controllers, right, in a storage array. And we work very close. So there's a couple of challenges when you're implementing a virtualized storage platform that can serve, both, external storage functions as well as serve I/O to locally running guests, and providing high availability. And on top of that, being able to provide all the enterprise level features. How do I drive low latency sub 20 microsecond media? How do I handle PCI Express faults from NVMe devices, right? I want my customer, wants to be able to provide hot plug for these devices without having to reboot a controller, right? So in other architectures that implement it this way, where you have your storage function running as a guest alongside user guests, normally the I/O flow for the storage guest would have to go through, in this case, the ESX hypervisor would have to go through the ESX I/O path, okay? And that is adding another layer of latency. And then you're also relying on all the hardware management capabilities of that hypervisors. So what we did is, I don't know if you guys are familiar with Intel's volume management device, but this was an innovation that our Dell server team worked with Intel years ago. And the Intel volume management device is a device that allows you to constrain or catch PCI Express errors so that you can handle them out of band. If you were to let those PCI Express errors, because they're not buffered by a controller, they're directly attached to the CPU. If those errors traverse to the CPU, you can get a machine check, and nobody wants to do that, right? If we take a look at a SAS architecture, right, that's why there's a SAS controller there, right? You have your SAS devices behind it. The SAS controller catches any errors, like if you have a problem with the interface, for reseating, devices, that's caught by the controller. In NVMe, that doesn't exist, outside of VMD, right? So there's, in order to drive low latency for, say, storage class memories or NVRAMs, we wanted an I/O stack that can drive that latency. And by traversing through the ESX I/O stack, we couldn't achieve that. So we are leveraging VMware ESX has the capability of what's called VM Direct I/O, direct path, right? That's basically where you can pass through a number of PCI Express devices. And then as long as those devices handle a certain type of reset capability, you can pass them through to a guest, and then that guest can use their local guest drivers, right? However, that's only limited to about 16 PCI Express devices. If you look at PowerStore, it has 25 NVMe drive slots, in the front. We also want the ability, Ray, like you were talking about before, the ability to serve both Fiber Channel and iSCSI block and file protocols externally, while at the same time being able to have those user guests also access that same storage, right? So there's other devices that we need direct control over. So We work very closely with Intel and VMware to leverage Intel's volume management device. And when we first tried to use it, it didn't work, right? It didn't work in a hypervisor environment. There needed to be specific support for it. But we did work with them. We did co-develop a solution with Intel, VMware, and the PowerStore team. We delivered this capability in vSphere 6.7 Update 2. And what it provides us the ability to do PCI pass-through for a large number of devices, larger than 16. So basically, we were creating this guest managed infrastructure domain where we hide all of these devices from the hypervisor. And since we put them inside this domain, we can just pass through that one function, that one VMD function through to our guest. And then behind that, we can then have our guest drivers address all of the devices behind it. We also have the ability to support plug and play, right? In some competing architectures that implement similar architectures, you have to reboot the node when you insert a new device. We don't have to do that. We get native plug and play. Okay, so for serviceability, that's great value to our customers. We also have the ability with Direct IO to drive our low latency, right? The person who can drive the utilization of this media is the person that's going to win, right? So we get bare metal performance on a per core basis out of our storage guest between PowerStore T and PowerStore X. So 10 cores, say for example, 10 cores of PowerStore X performance is equivalent to the same 10 cores of performance on a PowerStore T. You think of it that way. I already talked about PCI fault containment. That's another advantage. And the other thing that we work with is with VMware and Intel on is
Dan, can we break for a second? Because that's a lot of information, a little bit nonstop there. Can we take it one layer higher and kind of get some definitions here? One, why is this a storage array, the X specifically, and not a converged system? Because it is a converged system by definition. And then two, can you talk about the specifics around, just from a high level, what Intel family of processors are you using? And the second thing that's a little confusing is resource management. So from a hypervisor perspective, we're used to, in these converged type systems, ESXi being the core hypervisor being managed or the king of the hardware. That doesn't seem the case in this. So can you answer kind of those three things? Why product category, why is this not categorized as converged system? Two, what Intel processors are you guys using in the X series specifically? And then three, what's the underlying controller for the resource contention?
Add one to that, and that's predicted use cases. So where do you see this fitting? That I think that adds on to Keith's question there. That's okay.
Well, let's start with that last question first, because that's the easiest one to answer. So if you take a look at the mid-market, our customers are very cost sensitive. And so, when we're looking at both, traditional use cases and also emerging use cases where we can expand that, we want to be, we're getting a lot of feedback, from our customers, and we wanted to expand our market use cases. So you want to do more with less, and you want to do it easily. So it's really about consolidation, right? How can I consolidate infrastructure? So if a customer has, say, a few, applications, whether they're domain controllers or what have you, they don't want to have to manage extra hardware infrastructure, but they also have a need to serve, traditional mid-range storage functions for external storage. This provides a nice option for them. It's a nice small footprint. It doesn't require multiple storage arrays. So from a consolidation perspective, that's really nice.
Let me give you a couple of examples there. And Keith, to answer your question on processors, these are Intel Xeons that are consistent for the T and the X. So that's common architecture there. It's just how we divvy up the cores between the T and the X model.
So Xeon is a very broad term, like specifically what this is. This is Skylake. What generation?
This generation, the current generation Skylake.
Yep.
Okay.
And as we as we look at the deployment use cases and methodologies, as Dan's talking about here, and I flipped to a different slide on the screen for edge-based deployments, there's a lot of interest, especially at the edge location or at remote office locations, around deploying this and using localized deployment applications. These are very different than, say, this is different than hyperconverged. So, Keith, to your point, okay, you've got somewhat of some converged here. You're running applications and storage and compute kind of localized in an appliance. It is completely different than, say, a hyperconverged model, where hyperconverged, everything scales linear, right? You've got CPU, memory, and storage that all scales in a linear fashion. We have the ability with PowerStore X to independently scale the storage aspect and simultaneously run a subset of static applications. And I say static applications because we are limited to those two controllers and the resources of those particular two controllers. As far as CPU.
I had a question then. Why didn't you start with Kubernetes and maybe a serverless kind of functionality, containers, and you have full control of the infrastructure, especially on the file services. So if you think about surveillance, every time you have a new file coming in, you can do some compute work on top of it without moving it around. And it's, there are a lot of applications now that use this kind of methodology.
So we actually, serverless meaning, horizontally distributed, scale out data planes.
Well, I think about notifications, messages, and then, running something that, directly on the controller. So removing all the hypervisor and, the file system.
Well, there's challenges with that, right? So so we do have a container-based operating environment, and that's something that we looked on very early on, is the desire, there was this movement to commoditize virtual machines with containers, right? And that's still not solved today because of security and isolation reasons, right? Containers share the kernel. So if I were to allow a customer's container to run alongside my storage container, I'm at risk. My customer's data is at risk. Okay. The only way to truly solve that is with just enough virtualization. And we haven't seen the market solve it today. So typically, if a customer is going to run their Kubernetes environment in a multi-client way, or to protect themselves against the storage and security functions that they have, it's going to be wrapped in some level of virtualization.
Yeah, and actually, that was where I was going based on Keith's question. That's actually where I'm going, and is kind of asked. I've got 3 extremely large customers that I've met with over the past several weeks that are looking at this at edge-based retail locations, for example. One of those retail locations has several hundred locations globally. And they're looking at this because they want to create an application development model for their retail applications that's more based on containers and being able to deploy containers, at those edge locations. So, for example, it may be at a checkout kiosk, for example, being able to run a container-based application that is doing some type of security scanning or security monitoring, or maintaining the live camera video feed, or also the actual database that's handling the local inventory schema, right? And running that in an environment that allows them to create and then move forward with, say, for example, integration in the future with vSphere 7 and all of the integration with containers that's coming there. This is a very attractive offering to say, look, I've got a single, to go back to Keith's point earlier, where you've kind of got this, converged stack. So now inside of a single appliance, I have a single package that updates everything. My ESX is getting updated as well as my PowerStore operating system. So the storage environment, the underlying hypervisor, and any associated firmware is all being updated out of a single package and single deployment methodology. Simultaneously having independently scalable storage that could go in a single 2U form factor, at 4-to-1 data reduction, we're hitting just shy of 1 petabyte in the current configuration option.
Hey, Jodey, I have a question since you talked about vSphere 7. So this sounds like you guys are following the VxRail model, is just the best way to put it, where this containerized area, where this not containerized, where this area will depend on having integrations tightly built with VMware or whatever you're offering. So which version of vSphere are you currently offering with this? And then my second kind of related question is, this seems like BitFusion would be a fantastic application to be running, especially when you think about also centralizing GPUs. So like, are GPUs available? Are you guys working with BitFusion?
Yeah, so let me answer the first question on the versioning. So I threw up this slide. This will give you an idea. So the PowerStore OS for PowerStore X, it is a prepackaged bundle that comes with the validated version that we're supporting for ESXi. That is 6.7 update 2, as Dan mentioned earlier. That's what we're rolling out in version 1. We'll have a service pack that'll come out. That'll be the think of it as PowerStore Service Pack 2, for example, just maybe the nomenclature is different, but it'll be a service pack that will then encompass 6.7 update 3, right? And then we'll align a future release that will then incorporate ESXi version 7, right? So the way that operates from a customer perspective is the customer does not independently deploy or manage that ESX structure. That is part of the single consolidated validated package that comes from Dell EMC storage, right? So it's a single package that downloads into PowerStore X, you deploy it, and then it's updating the underlying hypervisor that's running on bare metal in the storage controllers, and then the entire stack up from there. So that's the version we're shipping with today and how that methodology works moving forward.
So Jodey, does that mean customers can't update if they want to? So if they wanted to go to 7 so they could get BitFusion, are they able to do that?
No, not until Dell EMC storage releases that version in collaboration with the bundled PowerStore X operating environment. Right? And so to answer your question about GPUs,
that can be so how do you do that from a security perspective? So something goes wrong and you have to update because there's a security leak or something like that.
Right.
You have to wait for you guys to come up with an update on that?
Yeah, we actually have in collaboration, with VMware and the engineering staff, that we have, if there is a CVEs or some type of vulnerabilities, that we work within a very specific time frame to take that's been pushed out from VMware and then roll that into a service pack to make sure that the customers are protected. So to go back on, Gina, the GPU questions, an interesting one. We don't support putting.
I can take that one, right? So Gina, you do bring a good point on, if you take a look at PowerStore today, we don't have the power envelope, to host GPUs, right? There are edge applications, that can do inferencing that don't require GPUs, right? But if a customer wanted to, do some sort of machine learning or have an inferencing application that really does require GPUs, you have to have a way to scale GPU as a service, and BitFusion is a great way to do that. So you could think of a PowerStore and a 2U and a Power Edge server with a GPU in it, or over the network, and you can offer those GPUs as a service using BitFusion. PowerStore X is deeply integrated with vSphere, and so getting to vSphere 7.0 is something that we're, it's along the roadmap. I can tell you that. We have been in discussion with VMware BitFusion, and those, that level, you'll hear more about that collaboration, in the future, but you're absolutely right. Now, if you take a look at our VxRail product that just released, the nice thing that they did is they're using PowerEdge servers with T4 GPUs, right? And so, if you have a vSAN cluster now with this capability, that's another application. The difference with PowerStore X is what we're really focusing on is that small footprint, right? And one of the things that you're going to hear about is, like, especially when you talk about our scaling model, we're really giving our customers, the ability to scale resources independently. And that's important, right? And a lot of these other solutions, they're not bad. They're really good for their use cases, but we're really focused on incremental scale, giving the customer the power to add a single drive, to add compute when they need to add compute. And then if you think about bit fusion, that really fits into that story. I need to add GPU when I need it and how I need it. A lot of times our customers would say to me, like, I can't tell you how many times I was in an executive briefing center, right? And, a customer would come up to me and they would say, hey, Dan, how come you don't offer object in the mid-range array? I was like, why would I ever offer object storage out of a traditional mid-range storage array? And they would say to me, well, I have a small demand for it now, and I don't have budget for a full-blown ECS. So if you can help me out by giving me a little bit of object until my demand and my budget increases where I can go to a solution, that would help me out, right? And, it was that sort of thinking that led us to this whole containerized architecture. But it's an example of how we have to be incremental in how we grow our resources based on our customers' demand and their budgets, right? So we're in business with these customers. And so PowerStore is really about giving them that flexibility.
Yeah, I drew this up on the whiteboard here, Gina. One of the customers that I was working with a few weeks ago, that was kind of their exact scenario. Was they were going to be driving, leveraging GPUs. They were going to be driving specific application workloads at an edge location, and in doing so, they wanted to simultaneously run a set of static applications, that were localized to the storage array. So they had this single consolidated footprint, but knowing that certain things were going to need GPU capabilities. Well, PowerStore X can service both of those. We can run those localized static applications. They can simultaneously throw in, a couple of 1U servers with GPUs, and then leverage externally attached storage from the same PowerStore X and have a highly scalable storage model that can support hundreds and hundreds of terabytes, without having to have, any kind of differing or massive growth scale.
Yeah, first of all, I love this whiteboarding online. That's awesome. But when you were talking about it in the first place, it just makes so much sense to combine the two. And I'm really glad you guys are doing that. That's pretty cool.
Going back to the slide, here in the slide, you said that the cluster basically is a 2-node SXI cluster, correct?
Yes.
Is the maximum size of this type of, let's say, converged solution for PowerStore X?
So the base
the maximum cluster size for a PowerStore X is 2 nodes.
So this really helps to understand also the use case, because if we are talking about a 2-node cluster, we know what we can do with the resources. Another question was about why we need ESXi Enterprise Plus. Are you using some specific feature of Enterprise Plus, like storage I/O control or so on? Because a 2-node cluster can be perfect for branch office, for edge, and maybe the license cost can be also.
Andrea, it's a great question. And actually, inside of the product group, we're actually having conversations and collaboration, with VMware and being able to potentially use their robo licensing model. So that's actually being discussed right now. Currently, we do require an Enterprise Plus license per socket. So it's 4 licenses per appliance. Understandably, that depending on your methodology in agreements with VMware, that could be expensive, right? But we actually are having discussions right now about potentially being able to use the robo licensing for these deployment methodologies. So stay tuned on that one.
Great. And another question: you have built this solution based on VMware Hypervisor. Are you also thinking to adapt for other hypervisor in the future?
Our current go-to-market and collaboration and innovation is with VMware. currently we don't have any plans to offer, say, KVM, for example, as an alternate hypervisor. So our strategy is to leverage VMware.
Okay, makes sense.
Now, we do have internally, we do have alternate versions of our storage stack running on other hypervisors. That's usually for dev test environments. We have a virtualized version that we use internally. But there's no plan to bring that to market.
So let's go back to slide 2, since we've got like 20 minutes left or something, and kind of feed back into the hardware basics, hardware design, and then we'll work our way back into those deployment methodologies and have further discussion as we get there. So to give you an idea, we're dealing with what we call an appliance. That appliance, the base enclosure, the terminology that we use within Dell EMC is base enclosure. That base enclosure is a 2U form factor that has dual controllers. And then Dan mentioned earlier, 25 slots on the front side. All right, so those 25 NVMe connected slots on the front side. You can see the drive support here, 3D TLC devices, 1.9s, 3.8, 7.6s, 15.3s. Just to give you an idea, if you'll note here, let me go into annotate mode here real quick, and then notice right here, and we'll classify this out on the next slide. But these are our NVRAM devices, and I'll talk about those in just a moment. But this basically gives us 21 user devices, or 21 flash devices that are capable of user data in the base enclosure. Those 21 devices at a 4-to-1 data reduction nets us out to right in the ballpark, just shy of 1 petabyte of effective capacity using the 15.3 devices. So if we go with the 15.3s at 4-to-1 data reduction, we can net out just shy of 1 petabyte in 2U. Now that applies to both the T and the X, right? So you can get a lot of capacity just localized inside of the base enclosure in and of itself. Digging in a little bit deeper into that, you can see here are the NVRAM devices. Over on the right side, we have 4 of those slots. We reserve those slots. Depending on if you're in a 1000 or a 3000 model, both T or X, it doesn't matter. It's the same for both of them. So if you're in a 1000 or a 3000, you only get 2 of those devices, right? Those are mirrored NVRAM devices. If you're going into a 5000 and up, you get 4 of those devices. We reserve all 4 of those slots. That enables customers to do non-disruptive upgrades from a 1000 to a 5000 or a 1000 to a 9000, right? So we can just populate those additional NVRAM slots, and now they can go from the most basic deployment model all the way up to the largest deployment model in the same form factor without having to do any kind of data movement or anything, just native to the base enclosure. Right? So that's kind of a look at the front end and the drive support for PowerStore in the base enclosure. If we flip it around, you'll see this is where we get into the controller sets on the backside and the expansion ports and connectivity options. If you'll notice somewhat of the purple color, or what's labeled here is the 4-port MES card, that's an embedded module that's there in every base configuration. It comes with that MES card. That is an IP-based module. We can support copper-based 1 or 10 gig, so you can do base T configurations, or that can be an optical module supporting 10 or 25 gig options. We can also add expansion ports or expansion cards. Those are the yellow or somewhat of an orangish color box, and those can be up to 25 gig Ethernet cards or the base T cards as well. Or it can be up to 32 gig fiber channel ports in there as well. You'll notice the blue ports, those are for SAS-based expansion. And so if we're going into an expansion enclosure, we'll actually show you that in just a second, what that looks like. But this is how we cable everything up. This is where we get our connectivity. to a PowerStore array. Going back, we just talked about the base enclosure, and that base enclosure supporting up to 21 devices. We have the 4 NVRAM devices, up to 21 NVMe devices, and then we start with a minimum of 6. So in any PowerStore configuration, we require a minimum of 6 flash devices. Once we hit the minimum of 6, we can now do incremental adds of 1, right? So a customer can just add a single drive and scale that up, by adding capacity in as small of increments or as large of increments as they want to do. If we go into an expansion chassis, so if we're going beyond the 21 devices, we're going to add a SAS-based expansion enclosure. So for those customers that say, for example, they're not so much concerned, with localized performance, they're more concerned with, massive amounts of capacity. We can clearly accommodate that, up to nearly a petabyte, in the base enclosure, and expanding that out, we can go multi-petabyte, inside of a single PowerStore config, and we can have up to 3 of the expansion enclosures. So base enclosure plus 3 expansion enclosures.
Quick question, Jodey, on that. Is the minimum number of drives due to an overhead requirement?
We're actually going to talk, we've actually got some content we're going to talk about how we do data protection, how we do basically our RAID design and RAID layout. And so you'll kind of see where that methodology comes in when we get to there.
Thank you.
Sure thing. All right. So we've just kind of went through the base enclosure concept. We can add up to 3 expansion enclosures on the base enclosure. And we also have the ability to scale out inside of PowerStore. This is different. So as Dan, eloquently explained at the beginning, we're targeting, mid-range customers. These are customers in the mid-range space at a mid-range price point. And so when you start talking about cluster designs and cluster capabilities, we are clearly meeting demands in the high-end space with technologies like PowerMax and Extreme IO that have InfiniBand interconnectivity, leveraging low latency protocols like RDMA, where you can have distributed IO, distributed workload across every available resource in the cluster. But with those additional technologies and infrastructure also comes additional cost. And so targeting this world for our customers in the mid-range, it kind of looks like this, and what kind of the industry has branded as, a loosely coupled cluster as opposed to tightly coupled. So it's more of a design like this, where we have appliance A, appliance B, appliance C, and appliance D. Each of them have a single storage pool, and all of these act independently. So if you have a volume, that's an Oracle, maybe your redo logs, right? You could have that living on appliance A. You could have your DB files living on appliance B. So you can distribute load across the cluster, but what we don't do is aggregate or span storage or CPU load across that cluster. So when we look at this, every single appliance is kind of its own domain. Does that make sense?
Sorry. So we had this discussion several times already. Isn't it more a federated kind of approach? Also, another thing is, what happens if I'm full of capacity, I reach my performance limit on one of the node pairs? Can I move the LAN undisruptively on another?
Yes. So your first question, Enrico, to the more of a federated design, from an industry perspective, having a loosely coupled cluster does follow that concept. So yes. Also, there's a ton of intelligence when we're going to get into that, where we'll actually show you how we have the ability to non-disruptively move loads from anywhere in the cluster to anywhere else in the cluster. But we can also do that in an autonomous fashion by, the logic and intelligence built into the array can actually make those recommendations in real time based on what's going on inside of the cluster. And even at the time of deployment. So even if you're creating a new volume out of the gate and you have up to 4 appliances in the cluster, we can actually, from an intelligence perspective, we can make the recommendation and actually assign that volume to the appropriate appliance in the cluster without you having to think about it at all. So we'll walk through that. Enrico, I'll actually show you some of those concepts.
Yeah, so Enrico, I want to add a little bit of color, right? So, we spent a fair amount of time looking at different scaling architectures, right? So your horizontally distributed scale out architectures, versus this more loosely coupled model, right? And when we talk to our customers, and we're really designing for mid-range with both transactional latency considerations as well as independent scaling to control cost and infrastructure sprawl, this was the choice that we made. So I mean, both architectures are good, but they solve different needs.
Well, I'm not questioning the architecture. Even this is a mid-range kind of product, so nobody needs 10 million IOPS volume from a mid-range product.
The thing that I will tell you, though, is
scale out and federated that,
the thing that is horizontally scaled here is actually the control plane, right? So a single plane in class that can manage their infrastructure, right? So that is. And the nice thing about it for our customers is, we can intelligently migrate workloads, whether those, applications or storage, to meet their demands economically.
So let me show you, while we're on that subject, real quick, I'll walk you through this, Enrico, maybe to give you a little better understanding. So this is a look at the PowerStore interface. So at the dashboard of PowerStore, you're actually getting a global view. You're getting a view of every appliance that's in the cluster. And note here, we have 2 appliances in this cluster. We can see, what's going on from a block and file perspective as far as what's provisioned. We can take a look at capacity, right? We can see capacity at a cluster level and data reduction. We can also see performance at a cluster level, right? So we can see things. To Dan's point about management and ease of use, we can have this single pane of glass that allows you the control plane of the entire cluster. So let me give you an example. If we're going to create, say, a new volume, and by the way, we have feature parity with REST. So pretty much everything I can do in the GUI, I can do via REST, and everything I can do in REST, I can do in the GUI. So whether you're using an autonomous deployment methodology, like say Ansible, for example, or you're doing native REST calls, or you're just going into the GUI, you have all of these capabilities. So if I want to go create a new volume, and I'm going to say, hey, first we're going to give it a name, we're going to give it a size, and from there, note here we have this placement capability. And in the placement capability, we have 2 different appliances. So we have 2 appliances in this cluster. Or we also have auto. So the analytics there, the machine learning is there to understand at a cluster level. So any appliance that we have associated within the cluster, it knows where's the best place to put that data set. So it is extremely intelligent and it's extremely easy to use. From an administrative perspective, you don't have to look at it and say, okay, well, how many appliances do I have? How many controllers do I have? Everything is done for us at the appliance level. So it's very simple and straightforward. So if we select auto, he's going to deploy that 10 gig volume, the best place that he understands, from an intelligence perspective to put it. Now, let's say, for example, this is a 10 gig, test volume or development volume. And I know, for example, that appliance 2 maybe is a 9000 series with all SCM devices. So it's a very high performance. And I don't want the autonomous nature to deploy a test workload, just out of that intelligence and logic capability over there. I can pin it, right? So I can pin the workload to a particular appliance if I want to do that.
You mentioned that you could have like 21 SCM devices in one appliance?
Yes.
Oh, okay. That's pretty impressive, actually. Okay, thanks.
Yeah. So the base enclosure. Let me go back Ray, and show you.
Yeah, no, I understand. I'm just trying to understand. It wasn't clear to me whether it was a limitation on SCM devices or you could populate the whole damn appliance. Excuse the French.
You can actually populate so in version 1,
Yeah.
Storage class memory is 21 devices in the base enclosure.
I gotcha. That's good. Thanks.
Sure. So you can see this autonomous nature here by setting auto capabilities. We also have some capabilities when we're talking about moving workloads, right? So if we go up to the migration tab, we see here migration actions, internal migrations, right? So we can see, do we have particular things that are being moved anywhere within the cluster, right? So we can see what's the status of these, what's the projection of these. If I want to move a volume, I can select a volume, and then I can actually tell him, hey, I want to migrate this guy or move this guy, right, from one place to another inside of the cluster. So we get all of those capabilities native inside of here. So it's really nice, even to the point if, for example, if we had a particular volume within the cluster that, let's say, was starting to fill up, and we hit a threshold or a marker. Let's just say, for example, I'm going to get a notification at 85% full, right? And at 85% full, I'm going to get some type of dialog box. The system's actually going to generate an alert, right? And as soon as I get that alert, I'm going to have to go in and acknowledge, right, that alert that I'm at 85% full on this volume. Well, one of the actions in the dialog box, it actually has the analytics that'll tell you, hey, in 8 days, you're going to run out of space. It will literally tell you, 8 days you're going to run out, or 30 days you're going to run out, based on the analytics and based on the trending of that particular volume in that particular appliance. Part of the dialog box is actually, do you want to do an assisted migration, right? So maybe you don't have the physical space to dynamically grow this volume, right? So maybe you don't, if you had the space physically, you could do that, but maybe you don't. So you can select that box and say, hey, yeah, I want you to kick this thing off for me. It will then pick that volume up and move it to another appliance in the cluster that has free space, completely non-disruptive to the host, right? So that capability is there as well, of moving workloads or volumes, throughout the cluster in an autonomous fashion.
Is this something you were working with VMware on as well? So they've got vRealize and...
This is completely independent of VMware.
Okay.
Now, we can do this in concert with VMware's DRS. So for, say, compute balancing, for example, that would be DRS. DRS will make migration recommendations to us, but we have internally our resource balancing and analytics that will actually either accept or deny those resource balancing actions based on internal things like the quality of service that's needed for that application, the capacity that's available across the cluster, the wear on the devices, the capacity forecasting. So it works in concert with DRS.
But some of your customers will probably be working with vRealize operations as well. So how does that hook into what you're doing here and what they're seeing in vRealize operations?
Yeah, we have full integration into vRealize. So customers can use vRealize automation and orchestration to dynamically assign a workload or move a workload, take action on workloads. We do have that capability.
And so because you have all of this analytic capability, does this help you size things for customers or make recommendations for customers based on the application workloads they're using?
Yeah, Gina, it's a great point. So we actually have a couple of slides on Cloud IQ just to kind of throw that out there. So all of this analytical data that we have localized within the cluster, the customer also has the ability, just via a checkbox, enable Cloud IQ. That comes free. Cloud IQ is free to our customers as part of a support agreement, right? And so that Cloud IQ capability is doing broader churning of analytics and looking at not just a single cluster, not just at a single appliance, but maybe looking at everything within their data center or multiple clusters that they may have globally dispersed, or at edge locations, as well as core data center, and taking all of that data into account and then making recommendations based on that. So things like, overall holistic growth patterns, hey, at this point, you're going to need to add capacity 6 months down the road. Like all of those analytics are being aggregated into Cloud IQ. And you're talking 39 billion data points. We've got nearly 40,000 systems already, working within the Cloud IQ structure, and that's growing every single day. So the analytical points get more and more and more. And there's a lot of logic within Cloud IQ that's taking that data and then extending that over into usable concepts to the customer. So they can generate, growth patterns, they can generate graphs, they can generate not just generating report type data, but you can also get content out of Cloud IQ like anomaly detection. So let's say, for example, in a particular cluster, let's say I've got a volume that's sitting over here on appliance A. And by the way, we support the intermixing of appliances within a cluster. So this guy could be a 1,000, a 5,000, a 7,000, and a 9,000, right? So we can have intermixed appliances within a cluster in and of itself. But let's say, for example, this particular volume at the host level, let's say he's normally running at 5,000 IOPS. That's as we've looked at the analytics and the trending within Cloud IQ, he trends that metric and says, that's the normal kind of working set area for that particular volume. And I've been an administrator. I've sat in the seat. I've gotten the call at 2 a.m. in the morning when something goes south. And let's say, for example, that this 5,000 IOP volume all of a sudden it doubles. It goes to 10,000 IOPS, right? So that might not be a big deal in a high performance flash array. It might go unnoticed, but the reality is that something changed within a very small window of time where you doubled that workload. Cloud IQ doing all of the aggregated analytics would then notify you, this is an anomaly, right? This is something you need to look into this, because maybe a DBA went in and made a SQL query change. Maybe an application change rolled out and something is now different. And 5,000 to 10,000 IOPS might not be a big deal, but 50,000 to 100,000 IOPS could be catastrophic, right? And Cloud IQ would detect and notify the end user or administrator about that. So not just with performance, but also things like capacity. You can do capacity analytical trending and notification as well. From an anomaly perspective. So, I've been down this road where, I come into work the next day and, I've got a 2 terabyte volume that went, from 900 gig to 1.7 terabytes overnight. And everybody's scrambling, trying to figure out what's going on, only to realize that somebody left debug logs on, right? And things started filling up like crazy overnight. Cloud IQ, with all of the logic and the intelligence, is scanning the entire landscape of the customer install base. And we'll recognize that anomaly and notify them on that. So all of that stuff is built into Cloud IQ within PowerStore.
Is Cloud IQ today or in the future going to have visibility to the full stack, so the Power Edge servers, the switches, even the applications?
So for those that may or may not know the history of Cloud IQ, we started it when we launched Unity about 4 years ago. That's when we brought Cloud IQ to market. Since then, we've rolled in the entire primary storage portfolio, and we're working every day to extend that into other aspects of the Dell Technologies portfolio. I can only really speak to the primary storage. We've done a really good job of bringing all of that stuff in, but I do know, working with the Cloud IQ team, they have a strong focus to bring other aspects, of the Dell Technologies portfolio into Cloud IQ. So I would definitely look towards that in the future, and maybe even ask some of those questions with the other presentations you're going to have today.
Jodey, I have another question here. Going back a little on the migration thing, can I also make a copy? Like, I have a system in production and I want to mess up with developers and other people that could run anything on top of the LAN on a snapshot. So I want to make a copy that is like a migration, but without moving, the actual traffic and creating new traffic on that LAN. Is
Right.
it possible?
Yes. So in this case, you would have, say a production volume that's running here. And in your case, you have a couple of options, right? So you could create a thin clone, right? So let's say that's a TC, a thin clone of that guy, which is still going to be direct pointers to that same data set, right? You could make that thin clone read writable, and you could have your host, that's maybe your dev host that is now, hitting that guy, right? But it's on the same appliance. But if you want to take that workload and move it off, you could then take this particular volume that's a thin clone, and you could migrate that to maybe a dev appliance or something like that, right? So you would have the ability to make those maneuvers, to put data sets where you want them, when you want them, and how you want them.
How so just thinking of a scenario now where you're moving a volume from one array to another array, how aware is the controller of what's happening in ESXi on that same array? So for example, you're running something at the edge on the ESXi that's running on it, you then move the volume somewhere else. Are you reliant upon the infrastructure for VMware moving the VM as well? Or do you go, that's running on a local VM on the other controller, we're going to speak to VMware, we're going to arrange for a storage vMotion at the same time as the data being moved?
So great question, Barry. So let me give you some insight here. What we're talking about with up to 4 appliances, right? In our current version, this is for the T model, right? In PowerStore X, currently, we only support a single appliance for PowerStore X. Now we have a strategy in the roadmap to change that to where we would extend scalability, multiple appliances for PowerStore X. But today in version 1, T scales up to 4 appliances. X is a single appliance. So in a PowerStore X deployment today, we would not be talking about the non-disruptive mobility of a volume across different appliances. However, we will look to do that into the future. And Dan, do you want to add any commentary or color around that?
So that's specifically for the PowerStore X deployment, right? Before, when we get to multiple PowerStore X clustering, it's all integrated with DRS. So, anything that you can do in vSphere today across hosts, you would get all of that same capability. This is where we get into how we integrate our storage migration capability with DRS, and we augment that decision making, based on various things that could be happening within the cluster.
Barry, does that answer your question?
Yes, it certainly does. Thank you.
Okay. All right. So here is getting into the data engine. There's a lot of things here. You've got the eye chart of a lot of different things here. But I know Dan specifically wanted to take an opportunity to walk everybody through the concepts of the PowerStore data engine and kind of how things are working under the covers.
Well, so let's just do a quick time check. How much more time do we have remaining?
We have 25 minutes.
Okay, good. All right. So I'm going to briefly touch on a few points within the data engine itself. To give you guys an idea, we get a lot of feedback, from both, media partner customers where they, we really want to communicate that this new data engine has been really built from the ground up, and it's a departure from the architecture that we've had in the past. And one of the biggest differences is that it's a log structured file system, or a log structured storage system. Uses a 4 kilobyte granular mapping, and it always writes fully consistent. So when we lay down data on the back end, we lay down full 2 meg stripes. That data that's laid down on the back end is fully packed. Right. So we built the data engine from the ground up for data reduction. And that means that we didn't want have any holes in the way that we laid out data, which meant we wanted to go to a log structured system. Okay. So that gives us the best efficiency. Being in the mid-market, the best architectural model that we can do is still staying with the dual controller HA shared disk model. We did change our caching strategy between other mid-range storage arrays where they would use a sort of a battery-backed mirror DRAM. We actually moved to a shared non-volatile memory transaction log using dual-ported NVRAMs. And the key difference here is that this is more aligned with our software-defined strategy, because as writes come into the system, they get written to the shared NVRAM, and then we only require a low latency, low bandwidth connection just to send a little record to the peer to tell him where that is, since the peer has access to that as well. And that fits nice if you want to take our asset and you want to move it into more of a software-defined model. You're not relying on custom hardware or PCI Express non-transparent bridging between the two controllers. Okay, that was another big difference. Obviously, it's built for Flash, supports both NVMe Flash, SAS Flash, and 3D XPoint. The redundancy engine and the data reduction I'm going to talk about next. So I want to clear up some of the confusion we have around, our parity protection. And then I'll talk about data redundancy. We do have share-based QoS. You can set that on a per volume basis, or you can use SPBM with VMware.
One of the aspects that's, let me show you that real quick while Dan's on that. Talking about the QoSing capabilities, and again, going back to the intelligence and the simplicity of the architecture for a user, is when you're creating, a volume, as we kind of went through this screen earlier, if you'll notice over on the right, you'll see volume performance policy, right? So you have high, medium, and low. So it makes it very, very intelligent and very quick for a user to assign a workload to a performance policy. And then that performance policy handles, the prioritization of those IOs based on high, medium, and low without having to get really complex or granular at any individual workload level. So again, it just goes back to the intelligence and the simplicity of the system.
One question about this, because if you're using a virtual volume, I guess that this kind of policy can be driven by storage policy from VMware vCenter, correct?
Correct. Yes. And that's what I meant by SPBM.
Okay. And the VASA provider, where is located? Inside the controller?
The VASA provider is located inside the controller.
Oh, that's great. And if you scale out or federate with 4 appliance, the VASA provider, you have 4 VASA provider because you have 4 appliances.
Well, we have 1 active VASA provider.
Okay.
Right? But there are 4 that are running. So if we had an entire appliance failure, we have another VASA provider that we just make active.
That's great to have a resilient VASA provider, because is one of the problem that you can have in a virtual volume approach. And last question about replication that I see here. Maybe you are going to talk later. But here I see that you have only asynchronous replication, correct? Some customer, for example, from Compellent SC series, maybe today they are using
live volume.
Live volume.
Okay, you got it. So is synchronous replication, or better, live volume, something in your feature plan?
Yeah, it definitely is on the roadmap. So you're going to see we're just months away from the V2 release, and you're going to see a lot more of those data services come into that V2 release. Yes.
Yeah. So one thing I'll say to the audience here is that building this product from the ground up, there was in order for us to consolidate our portfolio, right? We need to begin to consume all of the use cases for the other products as well, right? And also, there's some additional innovation that's coming with PowerStore. So we have a very rich roadmap, and this is the first of basically 3 to 4 major releases that are going to build out the storage. So you'll see that advance. This is we have enough in version 1 where we needed to get it to market, and we need to get the customer feedback and the reaction, right, and really understand, where the where the gaps are and how to prioritize what we need to deliver next. So version 1 is very fully featured, right? A lot of the things that people bring up, they're like, well, have you thought about this? Well, yeah, it's actually in the pipeline. It's just we couldn't deliver to the market with the quality that we wanted at the time that we wanted, right? So just know that there's going to be 3 to 4 major releases to realize the full vision of PowerStore.
So, sorry, do you have any plan for a virtual appliance for this product? I mean, many of your customer,
we actually are discussing a fully software-defined instance of PowerStore operating system. Of course, if you look at it in the context of PowerStore X, we already have a VMware virtual machine capable, right, instance of PowerStore OS. But we are having conversations with customers about potential use cases for an SDS version of PowerStore OS and how and where might that be used. But yes, those conversations, Enrico, are happening within the product and engineering team as well as with our customers on what potentially that need might be in the future.
Okay.
So I'm just going to briefly run through you our 4-to-1 data reduction guarantee. Of course, we had mentioned before that we're an active mapping layer between the two, so it supports thin provisioning, snapshots and clones. So when you copy, a volume, it's actually a thin copy, right? There's actually no data movement; it only involves metadata. Once we also perform pattern reduction for the most common patterns like zeros and ones. So as soon as a write comes into the system, we run through the data, check some of the data, and at that same time, we have the ability to detect well-known patterns and store them without having to store copies of that data, on the back end. So that's one form. Those are the first 2 forms of data reduction. For compression and deduplication, they're always on and they're inline. For compression, we are actually using Intel's Quick Assist offload. It's using deflate with dynamic. There's both static and dynamic. We're using dynamic, and it varies between levels 1 and 4 in Intel's terms, which really kind of equates to levels 1 through 9. We do have the ability to dynamically detect streams that aren't very compressible, and we will actually back off compression. Or if the system is under heavy pressure where the Intel offload engine starts to become overloaded, we'll actually back off the compression efficacy, say from like a level 9 to like a level 5, for example, to dynamically adjust the resources. In general, we want to make sure that on the right side that it's really the CPU that becomes the bottleneck, right? We don't want we don't want the compression engine to get in the way. One of the major things, architectural changes that I talked about on the last slide was really that we moved to a log structured layout. And this really allows us to take, so as data is ingested into the system, we quickly acknowledge the host. And sometime later, that's when we're going to perform the inline compression and deduplication, when we bind it from the logical space to the physical space. But when we do that, we're actually taking a bunch of data segments, organizing them, and then we're compressing them into a contiguous 2 megabyte buffer. And that buffer is just written out as a full stripe to the back end with no offset overhead. So it's very tightly packed, and we can do that with a log structured layout. And then the other thing that we're doing with respect to deduplication is we're doing a granular 4K block deduplication. And one thing that's different than our other products is that we have a global deduplication domain within the appliance. So there are no deduplication domains per volume. It's across all volumes within the appliance. So that provides some great opportunities for deduplication. With that said, we have a very rich roadmap for compression and deduplication. So along the roadmap, you're going to see some pretty significant enhancements and new innovation. I'd love to talk to you about them today, but I can't. But what I do want you to know that along with the other enhancements to realize the full vision for the product, there are going to be significant areas of innovation in this area. Okay. But what I can say is that, with the techniques that we made in the architecture and the inline data reduction, and the corpuses that we've tested with, we feel very comfortable. We now offer an average 4-to-1 DRR guarantee. So first off, I'm going to briefly kind of go over this to kind of give you an idea to clear some of the fear, uncertainty, and doubt. There will be a much more extensive blog that we're going to be doing on this to kind of get into more detail, and you'll see that on ITSIC's blog. I'll be working with ITSIC. But what I will tell you is that so PowerStore has implemented sort of a mapping system for the way that it lays out data, much like you would have a thin provision mapping system, for your volumes. We have the ability to fully distribute the segments for each of the resiliency stripes. So we can map around drive failures, for example. And it's this mapping that allows us to always write fully consistent. So we can map around drive failures. And since we're distributing the data segments, across all of the drives, we also have the ability to rebuild extremely fast. So when you talk about reliability, you're really talking about, what is the mean time, between failures, the individual drive, capacity, how large is the capacity, what are the number of drives you need to support, and then ultimately, in order to survive multiple drive failures that would render your data unavailable or offline, you need to stay within that availability window. You need a very fast rebuild. So PowerStore can actually rebuild up to a 1 gigabyte per second. Okay, so if we're talking about using parity protection, our dynamic resiliency engine actually determines what the appropriate level of protection will need it to be based on the class of data. And so that could be mirror, or it could be parity protection, or multiple levels of mirrors. So metadata will be protected, normally using mirrors or triple mirrors, and data will be persisted using parity protection. Our goal here was to provide fault resiliency to meet our availability goals, while minimizing our protection overhead, where we can make the most available physical capacity to our customers. And even using single parity schemes, what people need to understand is we can actually survive 2 drive failures with a single parity scheme. And the way that we do that is by creating something called resiliency sets. So when data is written to the back end, data is always written fully consistent to a resiliency set. And so with each resiliency set with single parity protection, you can survive a single drive failure. Matter of fact, you could probably do a little bit better than that, because the spare is actually distributed within the resiliency set. And since we have a very fast rebuild, we could remap around that and always make sure that we're always writing fully consistent. Right?
I think that's one of the key aspects there, Dan, is like noting that we allocate spare space. So even if you had a failure of a device and you leverage that spare space, at a 1 gig per second rebuild, all devices participating in the rebuild process, aggregating that rebuild happens very quickly. And then any additional space that's in the system can actually be used in the event of a failure. So if you have a lot of free capacity, you could literally lose another device and it would rebuild into that space. You could lose another device.
Yeah,
right?
So the thing there is to make sure that you're within the availability goals to meet your availability and reliability for your storage subsystem. Now, if you're using single parity protection, that's only going to get you so far. So what we've done is to make the trade-off between meeting our availability goals and making the most amount of storage available. We can distribute that across multiple resiliency sets. So if you think about it, say I have 2 writes coming in. So using single parity protection for the primary data, I can write 1 stripe to resiliency set 1 and 1 stripe to resiliency set 2. Now, within each of those resiliency sets, I can survive. I can survive a single drive failure, right? So that's the basic concept.
So getting into the intelligent landscape.
So let me just question. So you actually split up the data into two, or all the drives into two resiliency sets. Is that how this plays out? Depending on the number of drives. I mean, it's not like you have.
Right. So, for example, if we start off with a minimum of
6 drives,
right? So that would be with single parity protection. That would be a 4+1 plus another drive for a distributed spare. Drives work for a distributed spare, and that's distributed horizontally. So when data is laid out, right, we only need single parity protection to meet our availability goals. Now, as the drives grow, right, and your probability to encounter a drive failure increases, right? And it increases, also based on the amount of data that you have written, the capacity of the drive as well. We'll actually allocate a second resiliency set.
Yeah, that's all dynamic, Ray. So as the system scales, it will dynamically create that and auto assign that behind the scenes.
Yes, but drives are assigned to resiliency sets.
I got it. Okay, thanks.
So nobody, an SE or nobody has to sit down and try to figure this thing out. It's just the way that the system works. All right, so getting into the intelligent landscape here, as we mentioned earlier, we have, we launched the box on May the 5th of this year. We support vRealize automation and orchestration. We have the CSI plugin to allow for persistent storage and Kubernetes integration and orchestration from a container perspective. We also, on May the 6th, we pushed up our Ansible module into GitHub. So that's publicly available for customers that want to leverage Ansible. We have a full open set of RESTful APIs that customers can, independently program against. So the array is highly programmable from the outside, coming into the array. But there's a lot of logic, internalized within the array as well. So for example, we actually have something embedded into the cluster called the discovery tool. Basically think of it as this. It kind of allows the cluster itself to become plug and play. So we can actually start off with a single appliance, and then a customer just literally has to plug power into the new appliance and plug it into the network. As soon as it's plugged in with power and on the network, the cluster will actually discover that appliance. The customer can then say, oh yeah, that's a new PowerStore appliance. I want to bring it into the cluster. And then we have the intelligence built in to IP the controllers, build out the storage resource pool, bring everything online, and ingest that appliance directly into the cluster in an autonomous fashion. So it's very simple even to just scale out or to grow the cluster, very straightforward and easy to use. I gave you this example on the whiteboard earlier, so for the sake of time, I won't rehash this, but this is, hey, we hit a capacity threshold. We have the autonomous capability to say, hey, just by the check of a box, I can pick that volume up and move it to another appliance anywhere within the cluster that may have additional capacity, or I can move workloads anywhere within the cluster that I want to in a PowerStore T schema. We talked about Cloud IQ already, so I won't rehash these slides as well. And then the adaptability, want to make sure that we give some time here in closing for Dan to talk about, the concepts behind the container-based operating system.
Yeah, I mean, it's really simple. We talked about much of it before. You can read about it online as well, but it's no secret that when we re-architected our software stack, we re-architected it using a container-based operating environment. And the way that it was born was, I think it was back to Enrico, right? How do you run, without an ESX hypervisor, and how do you embed applications directly? Maybe that's just containers, and maybe we're just using Kubernetes. And I talked about some of the challenges around that, but we did see a benefit from our own perspective to create sort of a software-defined environment where we can take our best-of-breed assets, we can containerize those, and now we can offer to our customers, the same benefits of some of the technology in our portfolio and bring it to market so that there's, they have the same capability, same look and feel. We don't have silos of organizations, creating multiple assets that do the same thing. We can concentrate on one. So that's what I really talk about, leverage best of breed portfolio. We also wanted the ability to incrementally upgrade different components. So if there's, say, our file stack, has an upgrade, there's no reason to qualify the entire stack. We can qualify, our file protocol stack, and we can actually deploy that in a patch, and then the system can just individually upgrade that container. So these are all benefits. And of course, having a container-based architecture allows you to realize that asset in different forms. So, there was a lot of discussion today around, well, will you ever offer a virtualized version? Well, we kind of do already internally, but that's really used for our own development purposes. Whether there's a use case for customers, to use that, as Jodey mentioned before, that's something else. But it's this software architecture that gives us the flexibility to realize these assets, anywhere. So that's pretty much it.
Yeah, so we talked about PowerStore T a lot. This is just your standard deployment methodology where I've got my array, PowerStore OS running on bare metal, and I'm provisioning that. So all of the benefits we've talked about with PowerStore, in the traditional deployment methodology. We spent a lot of time early on talking about the deployment methodology of PowerStore X, the ability, with apps on to run literal VMware virtual machines, running applications directly on the storage array itself, but simultaneously providing highly scalable independent storage, right? That independent storage can be provisioned out, to external appliances. We can leverage, onboard replication to send that data back to the core data center, right? We can also have PowerStore X deployed and work in tandem with customers inside of their core data center. If they've got, highly scalable, highly performant, applications that they want running in a RHEL cluster, they can do that and simultaneously serve up additional storage from PowerStore X via Fiber Channel or iSCSI, right? Or we can simultaneously serve up external storage to a pre-existing ESXi server farm that's independent from everything else. So there's a lot of dynamic flexibility here. We can integrate in with VCF. So if you've got a RHEL cluster running VMware Cloud Foundation, of course, the management side of that requires vSAN, but we can run workload domains on PowerStore, right? So we can have storage expansion directly integrated into a VCF construct. Right? And if we look at this from a cloud integration perspective, customers running PowerStore X can actually run, the native capabilities of VMware Cloud on AWS and have native portability of those applications directly into VMC for disaster recovery or dev test environments or whatever it is they might want to do, leveraging native cloud integration with VMC. Or we also have our cloud storage for multi-cloud offering, where the customer in a fully operational model can have a PowerStore at a cloud destination that they don't have to purchase, they don't have to manage, they don't have to worry about updates, right? They're just getting a capacity, an annual subscription to an amount of capacity that they can then independently mount up to any hyperscaler that they want, from that perspective. So a lot of cool integration on the back end of there. Some people had questions about ingesting pre-existing infrastructure. We do have the ability to take parts of our pre-existing portfolio and pull that in. I'll show you just real quickly in the interface in the GUI. We have this option, import external storage, right? I can go to import external storage. It's as simple as, selecting the remote system that you have that's pre-existing from Dell EMC, adding, putting in your credentials. It will then add it to this configuration list. From there, I can select the guy that I want. I can say import. I select the volumes that I want to import. And if you look at the top, you'll see the workflow. It's going to give us the option to take those workloads and create and add them into a volume group or independent volumes inside of PowerStore. We're going to do our host mapping. We can schedule this import to kick off at a certain time, or we can do it immediately. It will auto-assign a protection policy, meaning as soon as that data starts hitting the PowerStore, it will start replicating and snapshotting and creating the protection construct automatically. And then you just kick off the import. So basically, we have host level visibility from a PowerStore perspective. So we can see what the host sees from an individual LUN perspective. We can also see what that storage array sees. We then sync that data across, mirror that data over, and then we cut over from a multi-pathing perspective. The host does a cut over to the new PowerStore array. So, that's kind of looking at things in a nutshell. We close this out with our anytime upgrade program, which allows us to do some clear differentiations in the industry, meaning we can offer our customers in PowerStore models the ability to have those upgrades as part of their support contract. So they can go from, a 1000 series to the next generation of the 1000 series as part of their support contract. They can also have the ability to go from a 1000 to a 3000 or a 7000 to a 9000. So you can literally do a full-blown upgrade, go out of family and go to the next largest version. And one of the aspects here that I think is truly differentiating is because we do have a scale-out architecture, the customer can take that investment that they've made and think of it this way. We have our select offering here, that standard offering here, and then we have select here, right? And with anytime upgrade select, since the customer is owed a controller upgrade, so instead of, here they would go from a 1000 to a 3000, they could say, hey, look, this thing can scale out. I'm doing fine. I want to keep my 1000, but I want to take that investment and I want to add your new 1500, right? And I'm going to get these controllers. So the customer only has to purchase any necessary expansion capacity, and now they're in a scale out model. So they can go from a 1000 to next generation 1500. They can go full blown upgrade from a 3000 to a 5000, or they can scale out. The kicker here, anytime in the contract, they don't have to wait some extended period of time, and they do not have to renew maintenance, right, with Dell EMC in order to take advantage of this. So going into the anytime upgrade out of the gate entitles our customers to do this anytime they want without going into any kind of long-term locked-in obligation with us.